So I had for you an actual talk, and then I'm going to rant about politics. The rant is a little bit unprepared, but that'll be fine because we're running low on time anyway, and at some point they're gonna yank me. But
Wait, yanking you's not on my schedule.
Oh yeah. Still look me in the eye.
Trust me, you won't see it coming.
I want to actually watch the slideshow, right? The current slide. Can you see that? Yes. Okay. Okay. Cool. So I have a demo, which is almost certainly not going to work because demos never work. I have terrible luck with live demos. All right. So.
Tom, you're outside the little border for the camera.
Where's the border? Is it this thing?
I kept stepping on that. You see the lines?
Yeah, that's the line that's broken.
Okay. Well, I should stay back here then because I got to run my presentation and stuff. So I travel a lot for work, and I'm tired of having to use insecure wireless networks everywhere that I go. There are many bad things that can happen to you on an insecure wireless network. This thing is the wall of sheep, which they have had at DEF CON since 2001, because there's an insecure wireless network at DEF CON. And so people take their laptop, they hook it up, they log into this insecure wireless network. And I think like most of these things are sort of things people don't realize are running on their laptop when they hook it up to the network. They've got their mail program that's going out there and it's like polling and stuff, and they don't really realize that it's doing that. It's amazing to me that there are so many people who are savvy enough to be at DEF CON and that are dumb enough to use the wireless network and actually expose their own credentials over it. And not only that, but they're dumb enough to do it year after year in spite of the fact that there's a huge wall in one of the rooms displaying everyone's passwords. So it goes to show you that no matter how sophisticated you are, chances are you're exposing credentials over insecure wireless networks. This was a talk that was given at Black Hat in 2007. It's this thing called sidejacking. And basically, it's cookie theft. And when this came out, we were not that impressed. We were like, dude, it's just cookie theft. But the fact is actually that this had a big impact. A bunch of websites actually adopted SSL as a consequence of this presentation because basically they automated the process of cookie theft and demonstrated that it could be used to compromise people's email and the like. And this tool is available. This thing came out about a year ago, Firesheet. And this is sort of like it's sort of like sidejacking with a really nice UI. You run it at a coffee shop. It shows you all these people over here on the left are people at that coffee shop who are logging into their personal profiles on different social networking sites. And what we've done is double clicked on this Ian Gallagher character, and it's logged us into Facebook as him. So we can now do whatever we want to his profile and send messages to a friend or whatever. So this is the risk of insecure wireless presented in a way that most people can really understand. And this also had a significant impact. A number of websites either adopted SSL or moved to default SSL after this happened. But and I think that's useful, but the problem is that there's still a hell of a lot of unencrypted stuff coming out of my laptop. And when I'm on one of these insecure wireless networks, it's still going to be exposed. This problem is going to continue to exist until I actually have a secure wireless network. So what about VPNs? Everyone's like, well, why don't you just set up a VPN? You can encrypt all your stuff from your laptop to some point out on the internet. Or what about my corporate VPN? So I'm not exposed, am I? And so the first thing is that it depends. Some of these corporate VPNs will encrypt, all of the traffic from your laptop to your corporation and then send it out to the internet from there. Others will only encrypt traffic that is intended for the corporate network. They will not encrypt everything. And so that, it depends on your corporate VPN. The other thing is that this is, for non-commercial use, this is really inefficient and you have to go to the trouble. There are some services out there. If you Google like wireless security, there's a couple companies that will sell you a VPN service for your laptop, but it's like, you know, $10 or $20 a month. It's a significant expense. So I'd like to see a more fundamental solution to this problem. So one way that you can do this is to set up a guest account. You can have like an encrypted wireless access point, right? And you can have a guest login and password. George Ooze suggested this a few years ago in a column that he wrote, and he suggested using PEEP with a guest account. And then when FireSheep happened, this guy, Chester Wisniewski, suggested a WPA, WPA2, PSK, the password-free Wi-Fi. So everybody knows what the password is. The WPA, WPA2, PSK approach is not a good idea because of the way that session key is derived in PSK. If you know what the password is, you can figure it, and you watch the session key derivation, you can determine the session key. And so as a consequence, this isn't actually much more secure than not having a password at all. However, George Ooze's solution is a little bit better. PEEP happens within an SSL tunnel, and so even though you know what the login and password is, you can't necessarily decrypt the tunnel. The problem with George Ooze's suggestion, and he's very clear about this, is that it doesn't protect you against rogue access points. So if the PhreakNIC wireless network was PEEP and it had, you know, a login of guest and a password of guest, anybody else could set up a wireless access point with the SSID of PhreakNIC and a login of guest and a password of guest, and you might choose to log into their access point as opposed to the one that's actually run by PhreakNIC. You can't tell the difference between them, and so as a consequence, you may end up logging into a network that's run by somebody that you don't expect. Does this all make sense to everybody so far? I'm just trying to like state the problem here. Everybody with me?
Yes.
Yeah.
All right, so in explaining this problem to people, I've had people say, well, this rogue access point scenario that you're talking about, that, you know, George Ooze's proposal could be you know, subjected to, that's ridiculous. Who would set up a rogue access point? I've had that feedback from people who are reviewers at academic conferences that have to do with wireless security. So here's a rogue access point. It's called a Wi-Fi Pineapple. It's available for $99 on the internet. And it actually runs this piece of software that will, so if you've ever logged into a wireless network, and you boot up your laptop may go out and probe for that network and say, hey, network X, are you still here? And the Wi-Fi Pineapple will listen for those probes, and it will say, why, yes, I am still here. Please come and connect. And then there's a bunch of tools on the Pineapple that let you like monitor people's activity and get their passwords and everything like that. And again, $99 on the internet. This picture is what they're selling today, which is Wi-Fi Pineapple 2.0. I like Wi-Fi Pineapple 1.0 a lot better because it actually came inside of a plastic pineapple. It was one of those pineapple drinks, and the antenna stuck out the straw hole. So you could like imagine leaving this somewhere, and people would be like, "Oh, it's just a pineapple," you know. Someone left their beverage here, and would be none the wiser that it was collecting their passwords. And so anyway, whatever. Yes, rogue access points are real. So let me restate this problem in a much simpler way. Wireless networking today is an options choice. You either require authentication or you don't encrypt. So here are two networks we can connect to. We can connect to insecure access point. It's totally unencrypted. Everyone can see everything we do. Or we can connect to home. But in order to log into home, we have to have some sort of login and password that's previously established with those guys. We don't need this to make encrypted connections on the internet. So this is PayPal.com. You can establish an encrypted connection from your laptop to PayPal.com. You do not have to have a login and password in order to set that encrypted connection up. In this case, now you may have an account at PayPal, but you'll note that I haven't logged in yet here, but I still have an HTTPS session pinned up. It's still asking for my login and password. The way this works, as everyone knows, I'll get to you, is that that there is a digital certificate that's issued by a trusted authority. You know, put trusted in quotes, and that's a whole other talk. PayPal has this digital certificate from a mutually trusted third party, and it's tied to their domain name. And so they use that certificate to pin up this encrypted connection with you, and you're communicating with PayPal because only PayPal, in theory, could have a digital certificate that was signed by your mutually trusted third party that is associated with their domain name. What is your question?
I was just going to say, did that sort of come from Dignitalk?
Right. So there have been some concerns about the SSL security model recently, and I can go way deep into that, but it's a bit of a tangent from this discussion. So I'll save that for the end if you really want to get into that. So this is what I want to create. I want secure open wireless networks. And the way that this works is that I'm actually using, in this example, I'm actually using a domain name as the SSID of the wireless network. So in this case, it's wifi.ibm.com. Only IBM could possibly run a wireless network with a digital certificate associated with that domain name. And your client, when it connects to this network, it forms an SSL tunnel the same way that you do with PayPal.com, and it checks to see if the certificate that was used in that session is the same, or is against the same name as the SSID of the network. Does this make sense?
Yes.
It seems pretty damn simple. Your traffic isn't, at this point, your traffic is encrypted from your laptop to the access point. You don't have to have a login or password or any credentials set up before you connect to the network. And you know who's running the network you're connecting to. Nobody other than IBM could set up a wireless network called wifi.ibm.com. So how does this work? So we use WPA2 AES TKIP. That's the sort of gold standard right now for wireless encryption. Sir?
Good question. Can you also have it show different websites for the domain name based on the IP you're access to?
Different websites for the domain
Like
name.
if I go to whatever.com, I can see different sites based on the connection I have through it. Does that question make sense?
I don't know what you're getting at.
It was just curiosity. I'm wondering if you can do it.
Well, so do you mean like once you've connected to the wireless network, can I screw with your DNS and give you different sites depending upon?
But depending on which wireless network you're connected to.
Sure. Yeah, I mean your wireless network provider has control over your internet experience, and this is why it's important for you to trust whoever it is that you're connecting to. You should not connect to a wireless network operated by someone you don't trust. And the problem with insecure wireless is that there's no way to determine whether or not you're connecting to a network that you trust. And so fundamentally, the problem is that any wireless network you connect to can completely manipulate your internet experience. And that's true of wired networks as well. The network operator has a lot of control and influence over what you see. And there's some crypto where people are talking about things like DNSSEC that might be able to prevent that. But a lot of that stuff's not there today. So anyway, how this works is we use TLS. TLS is one of the authentication modes in enterprise WPA. And the way that it's typically used today is for client certificates. So you'd have basically an enterprise would issue a client certificate to every person that works in their enterprise on their laptops, and they'd use those client certificates to authenticate over EAP TLS to the wireless infrastructure run by that enterprise. However, if you go read the RFC, this is the RFC for EAP TLS, and it describes this transaction that's used to pin up the EAP TLS session. If you go look at this RFC, it says, while the EAP server should require the client to authenticate, this is not mandatory, since there are circumstances in which the client client authentication may not be needed, such as emergency services or when authentication is occurring through other means. And so if the network fails to ask the client to present this client certificate, the client will not do so, and the network can simply allow the client to connect. This is one of those rare corners in the RFC that is not actually implemented by most people, but it makes perfect sense. So this is how, this is sort of a network diagram of how this looks like in practice. You have a secure Wi-Fi access point. Now you can use any off-the-shelf access point. I bought this thing at Office Depot. It is not modified. It is a standard off-the-shelf access point. In order to do enterprise WPA, what happens is your access point communicates with the Radius server. FreeRadiusD is an open source Radius server you can run on your Linux box. And I actually have that running on this laptop, this Ubuntu image. No, that's wrong. I have it running in a VMware image that's on this laptop. And so I'll boot that up in a second and I'll show you. So this laptop's Linux image will be communicating with this access point and providing Radius services. This laptop is the wireless client. This laptop will attempt to connect to a wireless network here, and authentication services will be passed from this access point to the Radius server running on this laptop. And there's a digital certificate on this laptop that relates to the SSID of the network that I'm going to use. And so this laptop will actually check to make sure that the certificate that it's issued matches the SSID of the wireless network. If those two things match, it will establish a secure connection. So the cool thing is that when I do this, I log into a WPA2 network, and I'm not asked for a username. I'm not asked for a password. I click on it, and bang, I'm connected. I got an IP address, and I'm encrypted, and so nobody can manipulate my traffic. Nobody can see what I'm doing, and I haven't had to authenticate. And so, in order to set up this demo, let me talk about this a little bit more. What we did is we modified FreeRadiusD, which is an open source Radius server. We modified WPA Supplicant, which is the wireless client software in a lot of Linux distributions, including Ubuntu. And we modified WICE, which is Ubuntu's GUI for configuring wireless access. So we modified those three pieces of code. Actually, we didn't really modify WICE in a significant way. We just created a configuration file that supports secure open wireless. The modifications to WPA Supplicant do the certificate checking that I mentioned, which isn't there by default. The change to FreeRadiusD is very minor, and it is to support the anonymous form of EAP-TLS that I mentioned in this RFC. In order to set up this demo, we needed a digital certificate. We went to, there's a company called Start SSL. Start SSL will give you a free SSL certificate. Their certificate is trusted by the default certificate store in Linux. There are other certificate authorities that will give you inexpensive or reasonably priced SSL certificates. So it's not hard to get an SSL certificate. So basically, if you wanted to set this up, all you'd need to do is get an SSL certificate, set up RadiusD with our code changes, and configure it to talk to a wireless access point, and you'd have a secure open wireless network. So what am I trying to do with this? Before I get into the demo, I have this is a long presentation where I can get into a huge technical discussion about the security issues with the wireless and why this is the right approach to solving them, and what kinds of recommendations we make for updating 802.11 in the future to support this. But the reality is that you can go get a free certificate, and you can download our code off our blog today, and you can set this up if you know a little bit about Linux and Radius. And it really doesn't take that long to set up. It really works very well. What I'm trying to do is sort of prove that this is a useful idea, that it's effective and simple, and that the powers that be that make some of this software and hardware should support this concept so that we can have more secure wireless networking everywhere. In order to do that, I have to prove to them that I'm not crazy. And so, there's a lot of people in this community that run hackerspaces and run Linux install fests and other things associated with the Linux community, where there's a lot of people with Linux clients, Linux laptops, that may actually want to, they may be running open wireless networks, they may want to offer a secure wireless network, and they may have people with Linux boxes who can connect to those secure wireless networks using the code we released. If anybody out there takes this code and actually builds an operational network like this and tells us about it, it's useful to us because it helps validate that we're doing something useful here. So I've been talking about this publicly for a few months now. There are a few people out there who've experimented with the code a little bit, but I don't know of anybody who's actually taken it and set up a real secure open wireless network somewhere. So that's really what I'm searching for, and I'm hoping somebody in the PhreakNIC community has an actual use for this, has a real open wireless network where Linux clients are accessing it, has a hackerspace where people would like to play with the technology like this. So this is what I'm trying to do.
Once we ever time, we will have it at the center. We've already got free radius and stuff.
Yes.
It's all there.
Did you have a question?
Well, I guess I kind of want to dovetail with some laws. So, I understand the importance of getting critical mass at some point, but
Well, I actually don't need critical mass right now. I just need one guy to validate that I'm not crazy.
no,
I need a credible network that is doing this, that can say, hey, this was actually valuable to us in some way.
don't think you're crazy, but when I think of my use case is there's a couple coffee shops around town that I study at on the weekends, and I look around at the general population there. Most people are on Macs, a few Windows. They got a D-Link router sitting in there that's probably 3 years old. They have to reboot it every 2 hours. How do you break through to that? That's where mine would be.
So, reaching Mac end users. So I'll say one thing. It is possible to connect to these networks using Windows and OS X today.
They're
but
not
the-
going to run Linux box with free radius. It's going to need to be baked into the hardware and server.
Well, okay, no, I'll get to that. That's a separate issue. There's the client issues and server issues. Let me talk about client issues first. Right now, we've released some code for Linux. We don't really have support for Windows and OS X clients. You can get Windows and OS X clients to connect to these networks by coaxing them. And basically by saying yes a lot to questions that don't need it, or providing phony answers to questions like, what is your username? Give me a client cert. Okay, here you go. It's not going to matter what you give it. The problem is that that's not really effective, and those clients are not actually checking the certificate to make sure that the name and certificate is the same as the SSID. So they're not doing the fundamental security check. Getting OS X support is going to be hard because it's pretty much closed source Apple land. And so at some point I got to convince Apple that this is something that makes sense for them to do. Windows is something I'm currently working on. There are a couple different potential strategies for Windows clients, there's potentially, like, I can modify an open source supplicant that can be run on a Windows client that will replace the built-in wireless stuff in Linux, in Windows. And if I do that, then you'll be able to fully support this from a Windows client. I just haven't got that code written yet. It's using the code we've released, you can do this from a Linux client. On the server end, so I acknowledge that you're right. It ultimately, for coffee shops to use this, it's going to have to be really easy. But I think that this whole radius server infrastructure can exist in the cloud. So they go into their wireless access point configuration, and they just put the IP address and username and password for the radius server, and they're using some service that's run on the internet. So they don't really have to understand much about it. And so I think that that's how this becomes usable in a coffee shop environment. I think that I'm not quite there yet. I need something more basic. I need somebody to like sort of validate that, hey, this makes sense. It works for us. We have a bunch of Linux clients. They're using this network, and having that external validation helps me convince other people that this is something that they should help me try to make more productized and consumable like that. I'm really in search of my first customer, if that makes any sense.
Tom, just two things. First, I still really intend to be
No,
that.
no, I
first
know,
house.
I know.
Because we actually did spin up Song, we got all the free radius, we got a Linux laptop packed together and all that, and we kind of tested it with, okay, everything's working, but we haven't done the proof. We haven't seen if we've changed the SSID, and then a bunch of shit came up and it just fell off the radar. But I still plan to be your first like 40+ radio enterprise Song. I'm really, trying. On the server side, one thing that one project you might want to find people working on and reach out to is the DDWRT stuff, the replacement firmware for all like the Linksys and Cisco routers.
Yeah.
Because they basically just put a Linux stack with a different GUI interface on top of something that runs a Linux stack with a GUI interface anyway. And they do have additional software and whatnot supported there. There's no free radius is small, it's tiny. There's no reason that a little free radius instance can't run on the little consumer access points themselves. And like the stack for DDWRT it should be very easy to wedge that capability in there, like an afternoon or an evening for somebody who's familiar with that platform.
Right.
So finding somebody involved with that particular open source project would probably be very helpful to you.
Yeah, I don't know if they're currently embedding a Radius D, and we haven't gone to the Radius community and said, please take our change in your released branch. They may come back and say, prove to us that somebody wants this, because it wouldn't be the first time that somebody has asked them to comply with this part of the RFC and they've said no. We haven't gone down that route, but you're right, like getting this to the point where the whole thing can live in here is useful. But the thing is that dealing with certificates and configuring certificates is hard, and so I'm of the opinion that having the whole Radius infrastructure in the cloud might be simpler, so that you can abstract away the process of getting a certificate.
Routers were never supposed to do DHCP, but they do now.
So if you go to the X-Force blog, which is blogs.iss.net, you have to go back to about June or July, like Black Hat time. There is a full paper on this. You can read all the slides in the stack to go through all the details. You can download our code changes. Everything is up there. If you Google for secure open wireless, it will be in your top 10 Google results. The link to all of the information about this.
In addition, it's probably not actually, it would be easy to implement this away where Radius isn't even in the mix, and you just upload the certificate to the AP if you have that kind of cooperation.
Well, the way that the protocols are designed, it wants to do EAP over Radius. Like enterprise EAP requires a Radius server.
There's also a benefit in not having the private key on the AP.
Yeah, but having
Yes, absolutely. Having the private key in a central location
You
on
could
the
offer a
internet.
service to the internet that basically provides this service.
Tom, this lady's
You would be
way
stupid to do this yourself.
The ability to start right now, but it's just plan.
Yeah.
So obviously this makes it more secure for clients to sign into the server and do what they want to do. What does this do to the liability to whoever's controlling the access point? I mean, if you're going to convince the average coffee shop to accept this network, you have to somehow convince them that nobody's going to pee in the pool or otherwise throttle the connection. There's something else that they can't control.
So today, these coffee shops are providing, that's a very interesting question. There's two answers. The first is that today, these coffee shops are providing open wireless. And so they're not necessarily doing anything to, this would not change the amount of information that they have about their clients. They would have the same amount of information they have today. Some of these systems, like in hotels, they frequently have a captive portal or gateway that you got to enter your room number and your name. And the problem with entering your room number and your name over an insecure wireless network is that anybody can see you do that and can potentially re-enter that same information themselves, or they can spoof your MAC address. So using this protocol and a captive gateway is a hell of a lot more secure than just using the base unit. Okay. All right. Is that better?
Yeah, it should be there.
Okay. So doing this with a captive gateway is a hell of a lot more secure than doing insecure wireless with the captive gateway. The other thing that's happening that's important to explain, that's a lot more complicated to discuss, is this thing called 802.11u that's being promoted by the Wi-Fi Alliance, the wireless industry, and there's a standard called EAP SIM. And EAP SIM is designed to allow you to authenticate to a Wi-Fi access point using your SIM code that you use to authenticate to 3G or 4G. And their idea is that your device, whether it's a tablet or a laptop at some point, or your phone, will have 3 or 4G on it. And so it will have a credential that's using to authenticate to the phone network, and that you will use that same credential to authenticate to Wi-Fi networks. And then basically anyone who's providing a Wi-Fi network will work with the phone companies in order to have that privilege, and that is how networks will be protected. And anyone who doesn't want to operate within that system, will basically not have encryption at all. And so there's a question about how much of the Wi-Fi world is going to be consumed by EAP SIM, and whether there are going to be networks that are not connected or interconnected with the phone company, and to what there's a question about to what extent we want to have wireless networks that people can access without authenticating. And I think that's a significant question. I think that you're right. There's pressures in society to say that someone who runs a network should know who is using it at all times and should keep track of that. I think that's a question that we have. Do we really want to be tracked every time we use the internet in a public place?
No.
Sorry, there's a question way in the back.
Two questions, thank you. The enterprise, on the server side, the enterprise certificate makes a lot of sense. But what was wrong with taking any authentication from the client side? You can just type in anything and the Radius server authenticates. You still get your tunnel.
Well, basically, I'm eliminating the need to provide to ask for that credential, so that you don't have to.
Well, then you never change the client. If you leave the client alone, it's going to type anything.
Oh, okay. So the problem if you leave the client alone is that the client needs to check to make sure that the common name in the digital certificate matches the SSID of the wireless network. If you don't do that checking, you're not secure. And so that's how you're preventing rogue access points. And that does require a client software change.
You mentioned that this one bit of software is based on the SIM, but it also works with CDMA phones such as Verizon.
I don't think it's turned on. Push it up.
A sizable chunk of the cell phone users in the U.S. do not have SIM cards because they use CDMA-based phones. So would this only work with?
I don't know. I think each SIM does not require a SIM card. I think it works with CDMA as well, but I'm not 100% sure.
Let's leave the 802.11u for another talk.
Demo. Trying. I need to restart this page over here.
Am I that drunk?
I am.
Is yours fuzzy, Tom?
It's 3D. You just don't have the glasses.
You just gotta do this.
It's only half.
This shit's so hardcore, it's fucking with your brain, man.
I got it. Here, I'll take it. It don't fit.
It was fine.
Tom, it strikes me that your like customer is not the coffee shop, which would be good. It's the people who make the access points. So you basically could say, here's a feature that would allow business customers to be more secure. And so like Bongo Wireless on an airplane, right? To now say, look, if you're a business customer, you don't have to worry about your credentials being stolen by someone else. And basically use that as a market differentiator to say, here's why you should use our Wi-Fi, public Wi-Fi points instead of somebody else's. And you can't go around trying to convert all the coffee shops.
No, I mean, I think that some of those, so the Boingos of the world, that are off, or go in-flight wireless. Those kinds of guys are potentially customers for this, and it could be a differentiator for them to offer this to their clients. You know, I do agree that you know that is that in the long term that's where I would like to go. Like going back to the discussion we're having here, this is the early adopter community. This is the community where I can find people who can configure a radius server. When I go to talk to business development people at those companies, they have no idea what free radius is. They don't understand these things. And so like these things have to like gain some traction in a community like this before it's possible to have conversations with those guys. If I could say that every hackerspace in the United States is running this, then they'll be like, oh, you know, it's something that it's an ad hominem thing, but you're communicating with people who don't understand the technology and aren't going to get a technical argument. And so they need to see it validated in terms of people actually using it. Sorry, I had to restart my. I'm a little drunk. I had to restart my my laptop because I needed to make sure that the VMware image booted up and got an IP address from this thing, which was not turned on the last time I started it. So now I have an IP, which is good, and so this should work.
Yeah, we can't read any of that. Just so you know.
You're on a different computer. Oh, you can't read any of that?
It's the same grade.
Oh, well, I don't know what to do about that.
We're all a little drunk.
I'll do the best that I can here. So
You can think of this as training for solving a problem when plastic.
when the phone, those bad days when the phone rings and you're 6 beers in. Okay, so right now the wireless access point is actually using an SSID, which is not the same as the SSID that's in the certificate that's configured. So this should not work. Let me open WICD here. And you can see that I can see this access point called sown.memestreams.net. It does not have a certificate for that domain. And so I'm not going to actually, I don't know if you can you read that at all? Is that down here, sown.memestreams.net, you can see it. So I'm actually going to use the command line tool so that you can't see what's happening. No, so that there's a reason that I'm doing this, and I'm going to walk around and see what it looks like.
It looks like something's happening.
So if you could read this, wow, what you would be able to see, it's trying this over and over again. It's going to say, doesn't match certificate, sown.memestreams.net is not equal to sown.riosec.com. So what the client is doing is it's getting the digital certificate that's being used to set up the ETLS session. It's comparing the common name in that certificate to the SSID of this wireless network. And it's saying, well, they don't match, so this is suspicious. I'm not going to connect to this wireless network. And unfortunately, Linux will try to reconnect over and over and over again infinitely instead of aborting. So we're going to hit Control-C. And what I have to do is go log into the access point and change its SSID, which should just take a second.
But it's a demo, it's not supposed to work. Harder.
Oh man, we're gonna get through this, and not only is it working, but I'm a little bit drunk.
So is the projector.
The projector is in fact the problem this time. Something had to break, right? That's what you want to break when you're doing a demo.
Yeah.
Because I can tell you what that says, and you'll believe me, which is even better.
People.
Okay, so the new settings have been saved. My wireless access point should have restarted. And so let's go over here. This thing, I don't like the way this works. So let's refresh. All right, so now this says sown.riosec.com. Let me explain. Riosec.com is owned by this guy named Chris Bird. Me and this guy Takahiro Takahashi were working on this stuff We found this guy, Chris Bird, on the internet who more or less came up with the same basic idea and was trying to advocate it as well. So we kind of joined forces, and we've been speaking about it together. So when we did a demo together of this at Black Hat, and we ended up using his domain. So I really do have a digital certificate for so.riosec.com on the Radius server. And if we click on the properties, we see that this is configured to use secure open wireless access as the encryption mode. So if we connect to this, please work, validating authentication.
And
Getting seasick. Big money, there, baby.
That's not smooth, right?
Damn it, Tom.
What the heck? I'm surprised actually because the other half of this worked. I can try it again.
It says obtain IP address.
It does, but I don't trust it.
Ironically.
we're putting interface down.
Because what's interesting is the Radius server is not saying that it's getting a request, and so something's weird with the
Power cycle the damn AP.
Have you tried turning it off and on again?
See, that was in stereo.
Reboot.
Ah, I knew it. Live demo, man.
What? Break with tradition?
Oh, wait, maybe that worked. It did work. Look, it's got an IP address.
No! No!
Yeah.
All right. Well, you don't mind waiting 2 minutes to log into the network.
Well, it's not that bad. I think that the access point was probably still booting up, and that's why it wasn't working. But it should be working now. And I'm able to gain the access. I'm actually pinging the Radius server right now from the client. So, so it works. So thank you very much. That's so please, if you are the kind of guy who knows your way around a Radius server and has a network that is an open wireless network that has Linux clients, please download our code. Please set this up. See if it works for you. Play with it and give us feedback because we need somebody to prove that we're not crazy. And this does work outside of this demo that I set up here on this table. So I don't know. Any other questions about this, or should I go talk about politics?
Tell us what.
No microphone?
He's got it.
He's supposed to be down here.
You're live.
So this seems to be fairly susceptible to the same attacks you see in SSL attacks.
Okay.
From cyber squatting, for example. OneGo.com or GoGo.com can be misspelled a plethora
That's right.
of ways.
Yep.
The exact same way. Is there anything built in to mitigate that, or are we just relying on people to not be dumb?
No, so that's a great question. There's some discussion of that in the long presentation that I didn't go through. Let me put it this way. I think that if we really institutionalize this, that the certificates that are used for secure open wireless should be different from the certificates that we use for websites. In this case, it's not. This is just a server certificate. If we had special open wireless certificates, then there could be a centralized database whenever we issue a wireless certificate. And so as a wireless network provider, I should monitor that central database to see when certificates are being issued and see if certificates are being issued that are similar to my name. If they are similar enough, I will have a valid trademark claim because these certificates are only used for providing wireless network services. And so in that narrow context, I can hopefully argue that that potentially misleading certificate should be revoked.
Now, from a technical perspective and a legal perspective, that makes sense. But from a business perspective, that's nonsensical.
Okay.
It's not practical.
Okay.
You're trying to come up with a new web process, or a new tree of process.
I mean, you said yourself, there's a website you can go to that gives you free SSL certificates that are in the chain of certificates of CA.
That's right.
Right?
Yeah.
How many of those are done a day? 2, 3, 5,000 a day?
I don't think it's anywhere near that. There are currently businesses that you can hire to monitor DNS in this way for you. to determine if people are squatting on domains that are similar to your domain or something to that effect. So I would say that those same kinds of approaches could be applied to this context.
I think the root problem, the root thing I was trying to comment on was the root problem you're trying to solve is somebody hijacking with your Pineapple Road thing. It's not solved by this solution.
Okay. So the problem that you have right now is that if you connect to an open wireless network, there is no way that you can trust it regardless of the circumstances. And so what I have done is I've created a context in which you can trust it, which is I've moved the bar. If you know that the network you're trying to connect to is wifi.ibm.com, and you look for that, and yes, it does rely on you to be somewhat intelligent and decide that's what you want to connect to, and not, you know, some joker's network.com. Then I provide you with the ability to make that choice. You don't have that ability today. You're right. A certain percentage of people who use wireless networks will never be capable of making those kinds of judgment calls. But the fact is that I think it's significantly more difficult for somebody to engage in a rogue wireless access attack. And so I've reduced the economic value of launching those attacks.
Okay.
Here, hold on. Just another thing to counter that too. It's like, I mean, this is a crazy time to have a talk about SSL trust with what's going on. But if you look at like the color coding stuff that the major browsers have done with certificates, that you can have a secure certificate, third-party trusted, and all of that, but you know you have to go through an extra leap of validation to be green. So like those in some ways are not technical approaches to a problem; they're human approaches because fundamentally you're trying to give more cues to the people and keep the people from being hacked. Those same type of approaches apply here, in that like different levels of trust should be applied to different certificates. It shouldn't be binary. Either I trust this certificate or I don't. You know,
In this room, everybody knows what a certificate is.
Yeah.
Outside of this room,
Here, get to the baton. Okay, that's not
inside
smart.
this room, I caught it. Inside this room, everybody knows what a certificate is. We know what a CA is, we know what a certificate is, we know where the chain of trust goes. Fair enough. Outside of this room is outside. There's bears.
Right. So I mean, the argument that you're making is that SSL has no value.
SSL does, and the color coding makes it a bit better. Right?
Okay.
It does, and SSL has solved the problem fairly well for the past 15, 20 years.
I mean, it is easy to set up a website, which is a misspelling of PayPal. PayPal. You can set up PayPal.com and have an SSL certificate for PayPal.com, and those attacks do happen in the real world. But you know, I think SSL is still valuable nonetheless.
I'd like to throw one more thing out there in regard to like the color coding stuff.
No, I was gonna push it up to your mouth.
Oh, okay. In regards to like the color coding stuff, you were saying that there should probably be a different certificate store or certificate authority chain for the type of certs that we use for wireless networks versus like, you know, standard SSL. Wouldn't it be neat if we could have that in the, you know, the cues it gives to people, tell something about like the retention policies and privacy policies of the network that they're on? Like, it would be kind of nice to see that there's an open wireless network that's run by some dude versus a wireless network that's run by like some sizable organization that, you know, probably is logging every packet that goes over it and stuff like that. If there's a way that the policy or the terms of service for the network that you're using could be reflected in like whatever trust indications you're getting, that would be awesome.
Right. Why was it still green? Right? Why was the one that was invalid still green? I think that's one, right?
No.
Well, no, when it had the wireless and WHD. But anyways, going on to the next question, because I think we beat that horse. Is our pedophile guy still here? No. No, okay. It's because the anti-pedophile guy, I guess, would be a better well, he referred to the legal stipulations that wireless networks, if they are unencrypted, then there are certain legal ramifications to the person operating the network. They're not culpable for what their users do because it's open, unsecure, and you know, it's not their responsibility. Does this change that?
No, it would take a court case and establish some case law But yeah, that's something that wouldn't make it across appellates. I'm not a lawyer, but I can, let me see. Prefixed by I'm not a lawyer, so I can't say anything significant about this, that's, whatever. But that's a really good point. And that's one of those things that would probably have to go to like, a kind of a, appellate court level. Because if the law says, if the network's encrypted, they have a different, set of requirements, then the argument would have to be made that just because it's encrypted, it doesn't trigger the thing that led to that judgment. If the network was authenticated, for instance, and authenticated in an anonymous versus, a non-anonymous way. But that's a really good point.
So I think there's two things here that it's easy to get bogged down. There are two attack scenarios this protects against. One is fire sheet, which is you're on a wireless network, you can hear everything else on that wireless network. Even if you needed to do guest to get on it, you hear everything. That goes away. Tom stopped fire sheet. Like ignore rogue access points. Tom just stopped fire sheet. Then there's the point of rogue access points. Is this access point that I am connecting to, is this who it says it is? Which right now is dependent on an SSL certificate infrastructure, which as we all know is not great. So even if that totally fails, I still think this is fucking amazing because no one, like fire sheet stops working. And even if you, let's say you're able to fake an SSL certificate, or even if some of these SSL infrastructure issues we're talking about, you do still pop up a rogue access point, you've reduced the effectiveness of that rogue access point by half, because Tom's network is still there, and then the rogue access point is still there. If you use Tom's network, you're safe. If you use the rogue access point, you're not. So you went from being 100% having your session cookies or whatever jacked to a 50% chance of connecting to the rogue access point, making the wrong decision, and not realizing that you are connecting to something that is not actually, the certificate is not valid. So I think it makes significant inroads into protecting against session hijacking, as well as understanding who you're actually talking to.
So, Billy, thank you for making those arguments. I want to add one additional point, and that is that if the network providers wanted to, they could make access to these kinds of certificates more exclusive. Now, I don't think that's a good idea. I think it's counterproductive. To me, open wireless networks, I think of coffee shops and hackerspaces and stuff like that. So I think that they need to be pretty open. But one option that they have is to say, we're gonna do a lot of validation of entities that have these kinds of certificates, and you could have an extended validation certificate type concept where you're providing a different user interface depending upon what level of validation the certificate had, which is exactly what's been done in SSL. So
I have more questions, but we'll take those offline. Fair enough. Let's let somebody else talk.
No.
Okay, so one of the proposals to fix SSL certificates, the way it's being done right now, is to use something like DNS to publish information about.
That's right.
I want to use this CA. I want to use this certificate. There's a few different proposals. Obviously, you can't do that with your system because you're not on the network yet. You can talk to the DNS server. You have
That's
to
right.
use the service that are in your. So, do you have? Is there an existing proposal that would work with this that has any traction?
So when you're hold on. So basically, you're concerned about the compromise of CAs.
Yeah, or
You're talking about using DNS text records as a way of dealing with the risk that the CA may be compromised.
Yeah, well, something like one of the, if say one of the solutions uses like DNS text records sort of thing to publish which CA to use or which certificate to use, but it looks like.
So there's this
DNS like found.
Right. So there's this. So are you familiar with convergence? Moxie Marlon Spike did a talk at Black Hat this year about convergence, which is a way of dealing with the same sort of problem, but by having a bunch of things called notaries that are out on the internet that all independently validate the certificate from different perspectives. The same problem exists because convergence has to do with querying a bunch of entities on the internet to see what their perspective on this server certificate is. Obviously, if you have a wireless access point, there's no way that these entities on the internet can query it, and there's no, when you're, before you get access to the internet, you can't make these kinds of requests. So I've been talking to Moxie about this a little bit actually, because it's, this application presents a special case where you don't have internet access, and so you can't do some of that validation. One way to deal with the problem is to change the way that you're approaching it. So one of the things that I think we should do with SSL is encourage websites to have multiple SSL certificates from different certificate authorities. So we have an idea right now that and there's like 200-300 certificate authorities, and you can carry a certificate for any of them, and one of those certificates is enough for people to trust your website.
Do you currently present more than one certificate?
I don't think so. I think you can currently present more than one certificate. Like the protocol allows you to shuffle a lot of random stuff in it, but obviously there's no client software that would currently validate more than one certificate. But I think that's a direction that would be productive. That if people basically said, I'm not just certified by this certificate authority, I'm certified by all of these certificate authorities, and your browser could indicate to you in some way that 10 is better than 1, that this guy is really trustworthy because he's got lots of certificates we trust. That would be a lot more. First of all, we would have better trust agility than what we have now, which is, and it would also be a lot more secure. I think that same model could be applied here, where the wireless network could give you a whole bunch of digital certificates tied to that same SSID, and you can check them all.
Like somebody would have to have take Parasite and Komodo to get a rating of 100 GB.
Yeah, that's right.
Yeah.
And so that creates a higher assurance. It is not you do not get as much trust agility as you do out of Moxie's conversions, because ultimately the guy running the service gets to decide which of these certificate authorities he's going to use.
Have you tested this?
No.
Are you going to?
I don't know if I have time, but I think it's an interesting discussion. Right now this is an email thread.
Okay.
But I'm quite certain. I'm quite certain that you can add new stuff to what the server is handing down, because there's things like certificate replication. There's this thing called Open Certificate Status Protocol that you can use to determine whether or not a certificate has been revoked by a certificate authority. And then the web server can do this thing called OCSP stapling, where it takes this message that indicates that a certificate hasn't been revoked and actually includes it in the SSL transaction. And if you can include OCSP stapling messages in your SSL transaction, you ought to be able to include all kinds of other crap. And clients that don't support that stuff will just ignore it. And so I think that you can more or less include, it makes sense to me that you could more or less include a bunch of other SSL certificates, but I haven't gone any further than thinking that makes sense. I haven't tried to look at exactly how hard it would be to implement. Obviously, the servers would have to allow you to configure a bunch of them and hand them down, and the clients would have to, you could build a Firefox plugin, I think, that would do all the checking and provide the user interface stuff. So you don't have to get permission from a big company in order to build this concept out. But I don't know if anyone wants a programming project. That's a decent one, I think.
If you put me on the thread, I'll see if I can help.
All right. Well, let's talk about this after.